So in the previous Gen 3 repair video, we looked at these boards sent in by Jimmy. 6 of these were the 3rd gen or Gen 3 boards. As we can see here, all of these have the 5-segment fuel gauge. And while troubleshooting these boards, I wrote on here Jimmy, and many of them I put NP for no power. So as we connect these boards up, we see that they won't light up at all. And checking across this capacitor here on the left, we should have between 8 to 8.5 volts here coming off of this bus for the upper left coil of the transformer. We're getting 0 volts. And if we remove power from the board and ohm across this coil here, we see that we are indeed open. So in that last video we showed using low melt solder and removing the faulty transformer. Did the same to a donor board to use that good transformer, and then soldered it back on this board to be repaired. And after successfully replacing the transformer, we were able to get 3 of these boards working in the same manner. We still had a few more boards to look at. One that definitely had a transformer issue and voltage issue, but it was a little bit odd that the LED lights would still light up on it. That voltage was pretty low on that bus. And if we hold the button down, we flash red and green, so it's not like it's a reset needed. It's given an error condition, like one of the cell groups is not balanced or in a good condition. So I decided to write a question mark beside this one and save it for another video, because it was in fact acting differently. So one thing I didn't show in that video was removing some of this conformal coating. So this silicone does come off fairly easy. We can use one of these boards already out to go by to see how we can go around the edges to remove this silicone potty material. A lot of times you can just use a small screwdriver and go around and release it from the edge. On some of these, it is handy to take a small razor knife similar to this and just go around if it's not removing easily. I won't spend a lot of time showing the details of this, but I will show removing a good third of it really easily. Some of my very early Ego videos did show removing some of this potty material back then. I'm going to speed through a lot of this. And it's pretty easy to do both halves of the board like so. But it's pretty easy to get to the screws. We just have 2 like number 1 size Phillips screws in here. And as I mentioned in a previous video, you can't just push the board out with a button like the 1st and 2nd gen packs. The button is actually held in like so as an assembly. So no way to push on that and get the board to push out. Just in case you haven't seen it, this is what the Generation 1 and 2 boards were like, and you could easily push them out. After removing those same similar screws, I'm just going to work with this board a little bit more, removing the silicone, especially around the transformer for now. And I may remove some of the other parts of this later, but for now, we can get to the transformer so you can see what I'm looking at. This is the capacitor that should be getting the 8 to 8.5 volts bus voltage on it, being pulsed off of that transformer on the top left coil. A close-up of the board I removed the donor transformer from shows. Back now I have removed most of the silicone. I'm going to go ahead and hook the battery pack back up to the BMS board, at least the power connector on the bottom. And we are flashing, which is odd. As shown earlier, holding it down we get alternating green and red. Pull it out so we can see it better. Even though it's not odd to blink red without the balancing wires connected, I'll show you we got very low voltage on this bus, and typically we don't flash at all. So this is the first one that I've seen with only like 0.8 volts. I will say it's usually around 0 volts when we're having trouble, but this one at 0.8 volts, And of course our bus on the other side is good. Our roughly 11 volt bus is good. So somehow it's still triggering and flashing the LEDs. But even with our battery pack leads connected, it still flashes the fault. And we have narrowed it down to being a bad transformer. But with the power off, if we go to ohms, go straight to this coil that we're having trouble with, and yeah, we're 15 to 16K. So that is a bit unusual. It usually goes to the mega ohms or really high K ohms. We see we're good on the bottom left, on pins 1 and 2, pins 3 and 4, the right coil, we're good. So it's just our top left or our pins 5 and 6 coil. But a little bit of an odd failure, being 15 to 16 K ohms. I guess is the reason why we're getting 0.8 volts, but either way the transformer is bad. So all three of these as mentioned in the previous video and now this one. So back now after replacing that transformer. Let's see how it does. Let's plug it all back up. And here we go, moment of truth. Awesome. So there's repair number 4. We hold a button down like a reset or a check. We're good, we're all green. I'm not going to show the transformer replacement on this one, but we will show it on another one in just a few minutes. So awesome, that's great to have 4 now repaired with that same issue. Even though the error or fault was different, instead of just being no power or no flash, it was showing like a cell warning, but nevertheless it was the same failure. So that got this one with the question mark repaired, and it was indeed the transformer. So I'm going to write on here 3rd gen repair number 4. And I'll write on here as well, in case I do take it out and it gets separated, 3rd gen repair number 4. So this is the 5th board that had no power. I wanted to save this one for this video as well, because even though I know it is a no power issue and a transformer issue, this one is actually open on the bottom left coil on pins 1 and 2. We are open on pins 3 and 4, which goes out to our roughly 11 volt bus. The odd thing is the top left coil on pins 5 and 6 on this board actually shows shorted. So I do want to remove this transformer and make sure it's not a diode or something else shorted on the board itself. I'm going to go ahead and try to remove the board and just pry the little shield off of it. Let's see if we can actually see any reason for the short. Do we have any cooked or burnt windings? Don't see anything with the microscope. Let's just go ahead and remove it and make sure we're not shorted somewhere else. I'm going to use my isotip cordless iron. Going to work in the low melt solder. This is the same solder I used on the last one, just saved it. Try to work some into each pin. Very similar process as mentioned in the previous repair video. Just working some low melt solder into the pins, and it'll stay liquefied for quite a while here. And this is helpful on a lot of multi-pin things, but as we can see here, it's especially helpful when you have something like silicone that's keeping your component from being lifted from the board. And the silicone is stuck on this one more than most. But I am fairly confident that all of my pads are liquid. Definitely don't want to rip a pad, but just making sure here that everything's liquid. I'm just going to have to pry it off. It's stuck down at the very bottom. As we can see here, that transformer lifted up from the silicone. It was stuck down really well on the board. Just going to clean this up. This is our good board. We're going to save that low melt solder as well. I reuse that several times. It will get the leaded and unleaded solder mixed with it, so I don't want to use it a whole lot, but I can definitely get several uses out of it. Just take our wick here and Clean our pads up. The ISO tip iron working really well here. Yeah, so just checking across the board here with the transformer removed, and we either want to see megohms one way or about 300K the other, depending on the polarity it's going through the diode. So I'm happy with all that. The problem was definitely in the transformer. So I'm going to go ahead and put some flux on here and my low melt solder and reuse it, and go ahead and get this donor transformer off this board. We'll speed up through a lot of this. Same technique, just working the low melt solder in and breaking loose the silicone. We do have to clean a lot of the silicone off of this one. It come off with it. We're going to clean the low melt solder off the pins of the transformer, get it ready to put back. Apply the flux to our Gen 3 board. We'll set our transformer on here with the dot towards pin 1. Just going to try to get it to stick here. There we go. Just trying to do a lot of flux here and heat the pin up well, because we want the solder to flow through the windings wrapped around the pin or lead as well. So we'll just keep adding a little more solder to make sure it does wick up the lead of the transformer a little bit. That little pool of flux does help a lot. Let's clean it all up. We'll get our Q-tip, and then we'll get our brush, try to clean it up, get a lot of the flux off. And we'll zoom back out now so you can see just how tiny a lot of these components really are. So let's plug it up. And we do have power where we didn't on this board before, so that's a good sign. One more time here, I'll show you on this capacitor here, we should be getting our 8 to 8.5 volts, and there we go. We are drifting a little bit because of the LEDs blinking. That load is definitely pulsing a little bit. There's our almost 11 volts here, and we should be getting around 10.25, roughly 10.25 on these caps. We'll plug in our balance leads, and now we're going to get green. Oh, no we didn't. Maybe I got a bad connection here. I have unplugged these connectors a tremendous amount on this particular Gen 3 pack because it's the only one that I have. So I may be getting a bad connection on the connector itself. I am feeling some warmth on the board, but I believe that's just from the LEDs lighting up. They actually do generate a good bit of warmth their own self. If we hold it down, we're getting the alternating red and green. That's not good. Definitely thinks we have a cell issue, but we know our bus is good, so it's not a voltage issue now. I'm going to have to go through and look at this connector really well. I looked over the pins, I looked over the connectors, I looked at the wires in the back of the connectors. I probably spent a good 10 minutes troubleshooting here before I finally decided that even though I knew the pack was good and I knew our voltage was good on this board, I decided to go back and grab another known board and connect it. That way I'll know if it's a connector issue or something weird going on with the pack, just from all the swapping back and forth and maybe pulling on some of the wires. So this is the previously repaired board, putting back on here just to verify that it's still good. And we are getting, what? Nope. It started to go green, but nope, it's showing red as well. So we know this board just tested good on us minutes earlier. So I'm going to go all the way back to one of the first repairs. This actually is the first repair from that previous video. And there we go, we're going green. Oh, and then we go red. I do notice I do have some 3rd gen boards that act a little bit differently. And this is kind of showing it. But it's also showing red where it wasn't before. So it's almost like it showed I had good voltage, and then it didn't like something. More than likely it's a particular cell or individual cell. So at this point I had to take the pack apart, and I did find a loose connection inside the pack. If you're interested in more information on that, I'll try to post it as a separate shorter video instead of taking so long in this one. But I did have a wire that was a bad connection in the center of the pack. And whether that was an issue I had with this pack from the beginning and it started acting correctly, or if this is something I done just fooling with the wires a lot, I'm not 100% sure. But it was a soldered connection and really should not have broken off the way it did. Just to show you now with that repaired board, we do get all green again. So there we go, that's great. I'm also going to take time to try here. The one that I wrote on there, reset OK. This is one that was just showing a couple bars and then was going red, and I held the button down to do a reset on the pack and it actually flashed green. Went to like 3 or 4 bars and I put it on the charger and it charged for just a minute and showed full. And this BMS has shown like it's good ever since, so I'm going to keep testing it. But what I did was just held down the button like so for like 4 to 5 seconds. And these Gen 3s seem to have like a test or a reset mode. Whether it reset anything or not, I'm not 100% sure. But I have had a little bit of luck doing that with some of these. That was acting, a little bit weird. It seems to be a combination of holding a button down. Either it gives you an error or it tries to like reset and shows a few bars. And then putting it on the charger and establishing a connection with it and resetting. It must do a level reset. So definitely worth a try. It costs nothing. So this pack shows good now. So if you do want to see this battery pack repair video, I'll put a link up here in the top right to that video, as well as having a link at the end of the video. So now with this repaired, and the board has had that transformer replaced on this 5th repair, there we go. There's our green light on this one finally. So this is 5 repairs. So remember the one that we had the question mark by because it was acting differently? That was repair number 4. So there's 1, 2, 3, and 4. And this one is number 5. That didn't write too well. It stayed. Let's see. Let's get that off of there. We'll just say T1 replaced and 3rd gen repair 5. We'll write Jimmy on here as well to remind me that it came from Jimmy. And just want to take a brief moment here to talk about the differences I see here in some of these Gen 3 boards. So you may remember me talking about the lights acting a little bit differently. Well, it's not just that. If you'll notice, both of these are what I call Gen 3 boards, but you see this chip here on the right? It's actually on the back side on this board. Now both of these boards are Gen 3 boards. As you can see here, the micro is down here. We also have a little isolation slot right here above my finger on the board on the right. Right above where the power comes in, like they may have had some issues and tried to separate those traces a little bit there on the board with a isolation slot. We have clear coating around these LEDs where the others are just simply the same gray. I don't know the reason for that, but that is different. It's easy to notice the black connector on the top left of what I'm calling the version 2 of the Gen 3 board. We just see a few differences other than the microcontroller as well. We see a few transistors and things laid out differently here and here. The diode that we talked about being at the top of the transformer, actually on the version 2 is back to the left of it. So that placement is a little bit odd to me. Don't really know why they redesigned it so, but it could have been something to do with the development of the 10 and 12 amp hour type packs. Not really sure at all on that one. If anybody else has any better ideas or knowledge on that, please share it with us in the comments below. But just thought that was interesting that what I'm still calling a newer pack to me, the 3rd gen or Gen 3 pack, actually has a version 2 of it, it seems like. So altogether that is 5 repairs, and they have all had similar issues, and that being the T1 transformer. We had transformer issues in the Gen 1 and 2, but definitely seems to be more of an issue with the 3rd gen board or the Gen 3 boards. Not sure if it's anything to do with the LEDs pulling more current, being more LEDs for the fuel gauge, or if it has anything to do with it at all. But just talking about these transformers briefly, sometimes you'll see where it looks like the little hair-like winding has broken right at where it goes to the pin or the lead of the transformer. And I have tried to take a little bit of time and bridge the gap with some solder, and it's kind of hit or miss because you can get solder to stick and make a connection back, and then you have to be very, very careful here when you put it back on the board to resolder it. Of course, that solder can move on you. But I do get to write on this one, 3rd Gen Repair 5. I am getting really close to running out of my donor transformers, so I will be looking into replacement transformers in the near future. I'll be looking at a lot of these like Andrey was talking about in some of the comments and some of the communications I had with him. Like these that will have to be modified or have an adapter board, for example. Just putting the original end cap and BMS board on this battery and making sure everything's good with this pack again. So this puts me in pretty good shape, having 1 3rd gen pack and possibly 6 replacement BMS end caps or boards. So I definitely want to take this time to thank Jimmy Chan again for sending all these in. It was 6 Gen 3 boards altogether, the one that reset okay, and these 5. So I hope you found this video helpful. If you did, please like, share, and subscribe. I'm going to have some links down in the video description of some tools and items that I find very helpful on my workbench. Any of those links that you click on are affiliate links, and they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.